So guys, here I'm back again, and today's lesson is about Liskov substitution principle. So it basically says that the most generic class, let's say that's the most generic class we have in here, which is an abstract class by the way, it has two abstract methods. And right here below, we have a class car that extends vehicle and a bicycle that also extends vehicle. But the thing is, for a car, activate brakes is okay. It's gonna brake, get fuel percentage, it's gonna give us the fuel percentage. But for a bicycle, we can also activate brakes, but we can't get the fuel percentage. So in this case, we throw in here an exception which says this vehicle does not support this action. So that's the problem here. The subclass can't implement a method from the most generic class. But what the Liskov substitution says is that the most generic class could perfectly substitute the subclasses, but in this case it's violating, as you can see here. So every time you have this condition of a subclass not being able to implement all the methods that the most generic class has, you are very much likely experiencing a perfect way to apply the Liskov substitution principle. But in this case, we're gonna run this program. Let's see how it goes. So in here, I'm instantiating a new car and executing all the methods and also doing that for the bicycle. And let's clear this. PHP app. It should run perfectly and throw an exception. So for the car, we have that it's braking and we have 46% of fuel, and for the bike it's braking and now we have an uncaught exception. This vehicle does not support this action. Let's run it again so we can see the fuel changing because it's a random number. So now our car has 98% of fuel and the bicycle once again is caught in an exception. So in this case, as I explained before, once you have a method that you have to throw an exception, that's not what we want because we can't really substitute vehicle for the subclass bicycle. So for the sake of this example, we're gonna solve this really quick and really simple. So if we can't implement this, it shouldn't be here. But the thing is, if I can't have it in here, I can't also have it in here. So we get rid of this, and now the method is actually the method of get fuel percentage. Get fuel percentage is only encountered in the class car itself. So in this case, we cannot execute this method anymore, and we can save and run our app, and it's gonna work just fine. It's braking 43% and it's braking. So this is an example of applying Liskov substitution principle for these classes. The next lesson, I'm gonna use pretty much the same example to show you about the interface segregation principle, which we're gonna solve this in a different way. We're gonna have to get this most generic class and really divide it into classes, into more specific classes. So, but that's gonna be for the next class. I hope you liked it, and that's it for today.